Okay, before we start the 5.2 section, you need to know a few preliminaries that I feel like the book leaves out. You need your Pythagorean triples. You need to know about reference angles, the 30, 60, 90 triangle with radius 1, 45, 45, 90-degree triangle with radius 1, and quadrantals. Also, you need to know your trig ratios when the radius is 1. So the radius equals 1 just means that's going to be our hypotenuse. In this case, if our radius is 1, that means r is 1. So everywhere there's an r, I can put 1. So y over 1, let me put it over 1, equals y. X over 1 equals x. This would be 1 over y. And then you just, like we did in class, the ratios, you just do the inverse, do the reciprocal. Alright. In this case, just remember, sine of theta in the unit circle, unit means 1. Sine of theta equals y. Cosine of theta equals x. That's the main thing. So, first of all, Pythagorean triples. Sorry this is messy. I assume that you probably know this. If you know these, you're going to save a lot of time. These are your perfect squares. So for example, for 3, 4, 5, we know that 3 squared plus 4 squared equals 5 squared. Or 9 plus 16 equals 25. Alright. Or we could do the 5, 12, 13. That means 25 plus 144 equals 169. So you're not always having to do the Pythagorean triple if you know these. Now the Pythagorean triples goes on infinitely. So if we do another row here, all we're going to do is multiply each of these numbers at the top row by 2. So for 3, 4, 5 we get 6, 8, 10. For this one we're going to get 10, 24, 26. Excuse me. Or 64, 30. Whoops, not 64. 16, 30, 34, 14, 48, 50, and so forth. 18, 80, 82. They're just multiples. Now let's go ahead and do another row. Let's do the column 3. So what I'm going to do is I'm going to multiply the first row 3, 4, 5 by 3. So we're going to get 9, 12, 15. And then I'm going to multiply it by 4. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And you can keep going on and on and on. Okay? The main ones you need to know for my class and for your SAT exams coming up are the first row and the first column. So if you know those, you're going to save a lot of time because you're not always having to do this down here. And you will be quizzed on this, but we will probably kind of X out some of these down in here. So these aren't the ones we're going to be using that much. Okay. Now, when we're talking about the unit circle, we're going to use the 30, 60, 90 facts that the side across from 30 is A. The side across from 60 is A root 3. And a side across from the 90 equals 2A. You need to watch my video on the generator of special right triangles to see where this formula comes from. Now, we're going to be using this triangle a lot and the next one a lot. So you need to know this. So all we know is that our hypotenuse is 1. That means this equals 2a. 1 equals 2a. So a equals 1/2. If a is 1/2, then I'm going to go ahead and put the 1/2 here. And the side across from 50, I'm going to change the a to 1/2. And I'm going to put 1/2. Or, this is root 3 over 2. You're also going to be able to flip the triangle. So if the triangle was, and I can't draw, but let's just say this was the 60 side, this is the 30 angle, and this is the 90. So you would put 1/2 here, root 3 over 2 here, and your 1 would still go with the hypotenuse or the radius. So there we go on that. Same thing with the 45 degree. We know that you should have already seen the video, or we've done it in class, the formula for the 45 degree triangle. In this case, we know that 1 equals a root 2. So a equals 1 over root 2. We can't have a radical in the denominator, so we rationalize it, so we get root 2 over 2. So in this case, this side is root 2 over 2. This side is root 2 over 2. Now when we use our formulas, we're going to do sine of theta and cosine of theta. Sine of theta is your y. This is your y. And this is your x. So you don't really have to use the 1 here, because all you need to know is the sine of theta, if we're in quadrant 1, is root 2 over 2. Cosine of theta is root 2 over 2. Tan of theta, you just divide these two and get 1. Now, if you do 1 over, let's do this in purple, 1 over root 2 over 2, you're going to get 2 over root 2. If you rationalize it, you get 2 root 2 over 2, which equals, this is 2 root 2 over 2, which is just root 2. So these are root 2. And again, cotan of theta is 1. We will definitely be doing this in class. Okay. Now, these are called quadrantals. Since our radius is 1, at angles 0 degrees or 360 degrees, this point right here is 1, 0. At 90 degrees right here, since the radius is 1, my x is 0, my y is 1. This is your x and your y. X, y. My next one is 180 degrees. So it's 90. And we're going, this x is negative 1, 0. And then if we go for the y, this is 270 degrees. It's 0, negative 1. So sine of theta is y over r. So for theta to be 0 degrees, change this to 0. Y is 0. R is 1, which equals 0. I'm going to change all these. Let's change this to, let's change them all to 0 degrees. Because we can make it look like a 0. So let's just say these are zeros. Alright, cosine of theta or 0, is going to be x over y, x is 1, r is 1, so that equals 1. Tan is y over x, which is 0 over 1, equals 0. Cosecant, we're going to just flip this here. So that's 1 over 0. That is undefined. This is going to be 1. And this is going to be 1 over 0, which is undefined again. Again, this part in here we will go over extensively in class. Okay, reference angles. The book doesn't talk too much about reference angles. So a reference angle is basically quadrant 1. It's a positive acute angle that the terminal side of theta makes with the x-axis. Here are your formulas. Here. And we're going to do some from examples. So, if we have an angle that is 50 degrees, we're already in quadrant 1. So the reference angle of 50 degrees, let's do it this way. Our angle is 50 degrees. So our reference angle is also 50 degrees. Because it's an acute angle and we're in quadrant 1. So quadrant 1 is easy. However, in quadrant 2, we don't have an acute angle. This is the obtuse angle. So what we're going to do to get a reference angle is make this angle here, draw it to the x-axis. We're at 180 degrees here. So we're going to subtract 120 from 180, and our reference angle is 60 degrees, which is theta prime. So right here and right in here is 60 degrees. Another way to look at it, from what we're going to be doing in classes, you can make a bow tie or butterfly. And match it up here, and this right here is 60 degrees. So you'll get used to this. So if you don't want to memorize the formula here, just remember the bow tie. So this was quadrant 2. Quadrant 3, we want the reference angle. In this case, we're in quadrant 3. If we draw from here, we're going to draw up to the x-axis, and from here, the terminal side is at 150. When you go up, you get 30 degrees. Or basically, we're going to take 180 minus 150 degrees, and we're going to get 30 degrees. Or you can do the bow tie thing and draw here, and we're going to, this is the reference angle here. I'm going to color this in. Should match up to this, and that's 30 degrees. Okay. In quadrant 4, we're going to draw up from this 315 degrees, draw up to the x-axis, and that goes up to 360. So we take 360 minus 315, and we get 45 degrees. So 45 degrees is our reference angle. Okay. So mainly you need to know, if you want me to go ahead, I'll do the butterfly here for the bow tie. And again, this is really bad drawing. But here is our angle here. And it matches up to this triangle here, which is 45 degrees. Right?